worried about it. This is me not worrying.
All right, for those of you, looks like we got John Sheehan and James online. Once again, a reminder, thank you everybody for joining us for the last TWed of the fall 2015 season. These are our TWed lightning talks. We've been on mute for the last 15 minutes. That's why I'm reading. And 2 minutes a person. Once again, a reminder, thank you everybody. It's working.
Hi everyone, my name's Simon Ellis. I work with Jim. I'm a fifth-year PhD student, so I'll be out of here in a few minutes' time. I'm working on cognitive game playing. So what that means is taking the cognitive architecture that Watson uses and using it to play board games or tabletop games or role-playing games, anything like that. The wonderful thing about the cognitive architecture is that it lets you do very complicated evaluations and then merge them all together in ways that standard techniques of game evaluation don't let you do anywhere near as easily. So what you can end up happening in standard game trees, you'll go all the way down to this branching search tree that's guided by a heuristic. Whether or not you're using linear search or you're using multicolor tree search, you go down as far as you can, you propagate back up, and you come out with a best guess. With a lot of complex games, really, really complicated games, you can't do that because there's just too much information to search. So you need another way to search. Or there are other things. For example, you have a game with ridiculous amounts of imperfect information in it. You need another way to handle the search space because otherwise you're going to get into masses of probabilities and the search is going to expand again. So the other thing that I did was I went back to the question, how do humans play games? And I came up with a nice pipeline that's a cross between the Watson architecture and what I learned from getting people to play the games and talking about them. And I came up with some software hacks to say, okay, actually, I'm not going to worry about searching the entire space. I'm going to bring the search horizon close. So rather than trying to go 20 flies in the future, I'm going to bring it right up to now. The problem with that is you need to guide the play. Solution, strategy. Humans use strategy, we use strategy tactics, and then moves. Strategy is a general guiding principle, a heuristic for playing the game, which we use normally in the search tree. I've moved it out, put it at the end. I can play complex games, and that is cognitive gameplay.
All right. Thank you, Simon.
We're going for a hard 2 minutes.
We're going for a pretty hard 2 minutes. Is there a bell out there?
I'm gonna switch it. I switched it to timer, so we'll play.
Oh, good.
You'll get
a dainty riff.
I might have to undo.
All right, so everybody, my name is Ray Yan. This is my 5th year here at RPI. So the topic that I'm going to present today is called stream reasoning. So during the past decades, when the semantic web technology has been applied on a broad range of domains, and most of them are actually done in a static data domain. So that means we have a bunch of data and store in a disk database and use RDF all to model the data and describe metadata, and also provide a unique identifier to link all the data and put them together as an OpenLink data project does. So these data are all static and actually persistent on the disk storage. But on the other hand, there's not only static data on the web of data. There's also some streaming data on the web, and there's actually a significant amount of them. So semantic web should also concentrate on processing the streaming data, and that's where the stream reasoning comes. That's where the stream reasoning is generated. So stream reasoning aims to bridge the stream processing and semantic reasoning. The stream processing technology is pretty mature. They're able to process large volume amounts of streaming data in a say very high rate, updating rate. But on the other hand, the primitive operators like joint, filter cannot provide more insights of the explicit data. So that's why the semantic reasoning is applied against the streaming data. so as we can gain more hidden knowledge and the relations among the streaming data. But the problem arises when you try to apply reasoning against the streaming data. That is the scalability issue and also the reasoning time-consuming problem, stuff like that. So there's a lot of things going on, and hopefully you enjoy this talk. Thank you.
All right. That's great. Amar. Yeah, and make sure you, I think everybody has, but make sure you introduce yourself.
Oh, okay. Hi, everybody. This is Amar Vishwanathan, and I'm a fifth-year PhD student working under Professor Jim Hendler. And I'm going to talk about what we call pragmatic query reformulation in knowledge graphs. The part of the work that we did this summer and most of the fall. What this is about is, imagine a situation where people have networks which are constrained, and so these constrained networks can take only a limited amount of information. But the underlying data source is a huge knowledge network. It can be video, text, images, or anything of that sort. So now the person who's querying, obviously his network is constrained, so he wants to ask a question to the underlying knowledge source. So when he asks a question, how much information can you give him? There are times when he poses this question, there might be no information coming out, but obviously bandwidth is constrained. Can you give him either suggestions, better ways to query the underlying data source, or can you give him good information that gives out the layout of the data source so that he doesn't have to ask the same question again? And this is only because his network is constrained. And what are the techniques that we use to do this? One technique that we've identified is what we call being data aware. By being data aware, one is every time you issue a query, you want to make sure that, because every query is just a conjunction of triples, you want to make sure that there aren't any triples in the data, triples in the query that give empty results, because of which the query can be bad. And the other thing is, every time you identify those triples or you identify the query, can you actually say adapt the query to make sure that the kind of reformulations that you give, the kind of other queries that you can give, utilizing the schema, essentially utilizing inference rules, class and property hierarchies, can you give them better reformulations? And this should be adaptive. It should be adaptive with the schema available to him. And I think that's about it. If you have any other questions, you can ask me. So yeah, thank you.
All right, thank you. All right, so unfortunately I didn't project John Sheehan, but I can.
That's
John,
okay.
a second ago why I
Sure.
turn you up to 11, which is something unique to a Linux machine. All right, so go ahead.
All set? Can you hear me okay, John?
Oh, go ahead. Try it again.
Okay, can you hear me, everyone?
Yes.
Go ahead.
Okay, great. John Sheehan, I'm a second-year computer science PhD student working with Professor McGinnis. I wanted to talk a little bit about electronic health records. I was trying to think of a particular topic to cover on that, and I started thinking about the problem of medical identity theft. It's been a big high-profile issue, especially recently. I think one of the reasons the problem has been so widespread is there are so many electronic health record systems out there. Much of our medical data is scattered across multiple locations, and if any one of them is breached, our very confidential things like social security numbers and health insurance information gets compromised. So I was trying to think, how could semantic web and linked data approaches help solve that problem? And one idea is maybe there's a way for a patient to store their personal information in one location, secured and encrypted, and then electronic health record systems would have some kind of an encrypted key to index and reference those key information fields that are stored in one place. This way, by nature, electronic records would be depersonalized. There would be no need to worry if the record itself was compromised. It also wouldn't be as subject to a lot of the health privacy laws and HIPAA regulations. So I don't know, it may possibly be something worth researching a little bit down the road. That's it.
All right. Well, thank you, John. I'm sorry, it totally escaped me to put you on the big screen, but and I want to talk to you about this, by the way. All right, next, how?
Real fee is he has to cross his name off on the board.
Yeah.
Wherever he happens to do.
We'll wait.
Okay, hi, this is Howley. I'm last year PhD student working with Professor Heng Ji, and I just defended my dissertation. And I'm working with OG on the reformatting my thesis. So hopefully I can get it done. And my thesis topic is unsupervised knowledge enrichment for event extraction. And event extraction task is to extract the structured event information from unstructured text documents. And it mainly suffers from three challenges. The first one is the ambiguity. For example, the fire, word fire is about the shooting fire or just end of position, the layout fire. And the second challenge mainly comes from social media like tweets is called lack of context problem because tweets have a length limitation of 140 characters, so sometimes it's not, it doesn't have enough clues for the event extractors. And the third challenge is also comes from the social media. It's called the informal nature because they are created by individuals. So there are a lot of free use of languages and ill-formed grammars. So it makes the traditional event extractors usually fail to make the correct decision. And the traditional event extractors, they make mistakes mainly because they only focus on local context to extract local features to make the decision. And in our approach, we're trying to incorporate two types of knowledge. One is called within genre knowledge. That is to retrieve the the documents that are topical related to the test documents. And the second knowledge is called cross-genre knowledge. It's like to retrieve the documents that is talking about similar topics or events from other genres. So we try to incorporate all this information to the local context and to make the decision together. So this will provide us a lot of the gain compared with the traditional event extractors. So, yeah.
All right, thank you. Okay, you're not done until you cross it. It's not official. Evan, you're here.
Yeah, I'm here. There we go. I get 10 less seconds than everybody else. That's fine. Hi, I'm Evan Patton. And I'm not going to tell you what year I am because I've been here a really long time. And but my thesis topic is on researching description logics and how they can be evaluated on mobile devices. So we're all familiar with mobile devices. I'm sure pretty much everyone in this room probably has one in your pocket right now. And there's a wealth of information on these devices that really these apps ought to be able to interoperate and to work together in interesting ways to benefit the user. However, each app right now is mostly a silo of its own data, and maybe it shares that data with certain social networks like Facebook or Twitter. And what my research interest is really about is, could we enable semantic infrastructure on mobile devices that would allow applications to share data using OWL2 as the mechanism for encoding knowledge and doing integration of data between applications. Of course, one of the big problems is that these are very computationally memory-intensive algorithms that need to be applied in a constrained environment, and one of the biggest constraints is power. And so my research is really focused on how do you optimize description logic algorithms to try to reduce the amount of power used to make them run efficiently on mobile devices. Thank you.
All right. So is this one of your target
If Verizon had an open source development library, probably.
Hello, everybody. I'm Kara Reedy. I'm a first-year grad student working with Jim Hendler. My group is working on making new applications for a new computer chip that IBM is developing. And this chip is different because it's neuromorphic, which means that at its base level, instead of essentially being a series of switches like a normal computer chip, it works a little bit more like neurons and neural networks in our brains. This means that it can run neural network applications really quickly and without using a lot of power. So my application is an artificial life simulation. This means that I have an environment with a bunch of objects in it, some toys, some food, some rocks, And I have creatures running around in this environment who need to try and survive and hopefully enjoy their life while it lasts. They can learn from their interactions with the environment, and their brains are driven by artificial neural networks. These brains of theirs take the information from their sensors, that is what they can see in the environment, and also their internal sense of, are they hungry, are they in pain, are they bored, and they use that to try and make good decisions, and often a lot of times they die. They are capable of starving to death if they don't eat enough. So that is their pressure to not die. So these brains are written in a platform called Café, which can't directly be put onto this neural network chip. But in the future, we'll have access to a tool that lets us convert it into something that works directly on the chip architecture. And the hope is that I'll be able to run either many of these creatures at once and hopefully see some interesting emergent behavior, or I'll be able to run much more complex versions of these creatures, and again, hopefully see some new and interesting emergent behavior.
All right. Thank you. Thank you very much. Do we actually have the neuromorphic chips in our hands?
We have it. We're not allowed to use it yet because they're still working out export control.
Ah, okay.
Hi, I'm Robin. I'm a third-year PhD student working with Professor McGinnis. So this time I did an extension work to my previous work on the clinical operation identification. To briefly introduce the work is, previously I'm trying to find a matching to a clinical or medical operation to its possible or correct for expansion. So now I have expanded the topic to a more general use, which is trying to extract the medical synonyms among, for example, our PubMed paper or other free text, which is our training text. So what I did as a plus is before we train the word vector embedding models, I used some of our already existed not medical domain knowledge. For example, in UMLS, we already have over 2.7 million concepts, which is collected by domain professions. And all these 2.7 million concepts are grouped into almost 150 semantic types, and then in a more larger semantic groups into around 20. So if we use some domain-specific parser, for example, like MetaMap or medical ESG, we are able to pre-process our training data. For example, the PubMed paper with all the UMLS concepts annotated and tagged in the training data. So when we are training our embedding model, we can first add an extra layer, which is the semantic type and the concepts, which is tagged and extracted as an extra output of the output nodes in the neural networks. So in this way, we are actually having a semi-supervised training approach rather than the original unsupervised way, which can be more accurate but slower. Yeah, so that's the basic idea. So now I'm adding up with finding more accurate matching pairs than before. Yes, thanks.
Actually, if you stand forward where Robin was standing, you're lighted very nicely. When you stand further back, Robin, you can sit down.
Stand here? Further here?
Right, yeah. Or actually, just slightly to your right. Yes.
So everyone else stand right here.
Well, actually, there's little gleams.
Well, I don't have that problem. Hi, I'm Eric Amherst. I'm a fourth year part-time student with Professor Hendler. My work focuses on collaborative computing or collaborative cognition computing interfaces. We've been doing a lot with, you may have heard about the launch of the new CISL, the Cognitive and Immersive Systems Lab. So what I'm particularly interested in is in group cognition and collaboration in a situated sense, and not like the typical collaborative computing that people do online and with different interfaces or different devices. This is more about getting people in a same room, and also working potentially with agents like Watson and other applications, so that they can come together, form more quickly, have decisions that are informed by group consensus, that sort of thing. We're looking at everything from, we have this new platform called the Campfire, which some of you may have heard. We can talk about it publicly now because we filed all sorts of paperwork. Basically, it's designed. It's roughly a 6 to 8 foot circle, with screens around the inside and on the floor, so you can kind of sit around it like a campfire. And we have display surfaces inside, as well as we're augmenting with all sorts of systems and sensors and that sort of thing, so you can eventually gesture at it, talk to it, and all that. So that the idea behind one of the things that was a big thing with this IBM conference that we just had was about, well, how will humans collaborate with things like Watson? The idea is that a human doctor and Watson, from medical Watson, will collaborate together and come up with better solutions. So this is one of the ideas, or some of the ideas, about how to actually create interfaces for that, and also create interfaces for a lot of these systems that are just bigger data, lots more things that need to be visualized in new and kind of unusual, different ways. So we're going big instead of going small in terms of interfaces. That's the idea.
All right. So have you thought about distributed Campfire?
Absolutely, absolutely.
I still want to explore like using iPads or mobile devices to kind of dig into it.
How long do you prepare careless creatures?
Look good.
Are you perfect? You still have the glow of a new PhD. So we can shut off the lights. You'd be self-lighting.
Thanks, John. This is Li Yunfu, 6th year here, working with Professor Peter Fox.
Zero year.
I just
postdoc.
I just defended my PhD thesis last week. Thank you. So during my thesis work, I need to implement a prototype and to demonstrate the idea of transparent provenance capturing. And to do this, I go for the approach of so-called code rewriting. It's similar to what we found when in the implementation of Linux shell script aliases, which means you rewrite the user code to make the code more usable, because users don't need to input that much long code. And the goal of my prototype is that I need to add those provenance-related arguments to a seemingly normal function, but actually a provenance-aware function at runtime, so that users do not need to take care of all these provenance facilities. All the users see is just the normal function calls. To be specific, it's Python functions. But the actual code got executed by the platform is the provenance-aware version of the function. And lucky enough, I found that IPython kernel has this mechanism called cell magics that could be used to implement this function, so that when interpret a code cell, the actual code gets executed could be different from the user input, in which case the users will have a really usable platform. Thank you.
So, 2 hours to 45 minutes to 2 minutes. Go ahead.
So,
You're too tall for it. Awesome.
So I'm Han Wang, final year PhD student with Peter. So the work I'm currently doing is to construct a knowledge base from literature for some certain scientific domains, such as biomedical or earth science. So the idea is that so there are several steps involved in this process. So the first step would be to extract all the relations and the entities from the papers. So such that the entities will be the nodes of the knowledge graph, and the relations will be the edges. And with these extractions, so the next step will be to know which nodes can be merged together and which edge. So which nodes are talking about the same concept, and which relations are essentially talking about the same relations. So the approach I'm going to use is to find distributed representations, aka embeddings, to basically they are vectors for the entities and the relations. So with these vectors, you can know that and by using some similarity measure, you can know that some entities some entity nodes can be merged together. They are talking about the same thing, and similarly, some relations with similar representations can be merged together to indicating the same similar relations. So with this clustering and unifying methods, I can hopefully can make a nice and beautiful knowledge graphs with not so sparse nodes and edges. And then with this graph, scientists can have some good applications, such as they can have a very rough idea about the applications without knowing reading too much into the applications.
Right.
Yeah.
Yeah, perfect.
Hi, this is Jian, and I work with Professor Heng Ji, and this is my third year here. So this time I'm gonna work on relation extraction on triggers. Trigger is a word which is used to most clearly indicate the relation type. For example, if we want to know a person's spouse, then the wife and husband may be the trigger word. So in the daily life, when we want to describe the relationship between two arguments, we will usually use an indicative word to attract others' attention and help them to understanding the relationship between two arguments. And we can also mention them very closely so that people know they are relevant. So based on the observations, we can extract the relationship between two arguments in the sentence. For example, if we have a sentence and it contains two arguments A and B, then we can construct a knowledge graph or a graph based on the syntactic and semantic information. And we will find the most important word towards A and B and regard it as the trigger word. Also, if A and B are strongly connected themselves, which means they do not need any trigger word. So in this case, we can also evaluate the degree of connection between the two arguments, and if the score is very high, we can also think there is a relationship between the A and B. So that's my method. Thank you.
Thank you.
Hello everyone, I'm Bo Liang. I'm a second year student in this group. And this very one I'm currently working on is called languages. So name tagger basically is a tool that used to tag those names in the plain text, like person names, organization names, and locations. And for English, the name tagger is well studied, and it can achieve very good performance that is comparable to human beings. But for low resource languages, since we don't have much annotation, and so we can't do supervised learning. And so what I'm trying to do is trying to use the knowledge in English side and transfer it to the low resource languages side. And I used a word alignment tool to align the low resource languages sentences with English and try to get the knowledges from English and apply them to the low resource language name tagger. Yeah. Thank you.
Hello everyone, my name is Dong Tao Zhang, and I'm a second year PhD student from Professor G's group. This year I'm continuing with my work on cross-media information extraction. So I just want to utilize information from both images or videos and texts. So currently I'm working on the cross-media inference. So for example, if in the on the newspaper, I read an article says there's a very brutal demonstration at some place. Then if I apply some computer vision system on the images associated with the article, if I detect there's some cake, flour, or like sandwiches, there must be something wrong. I want to use some information to eliminate those wrong results on the computer vision system. Vice versa, if I got a very brutal image, for example, some people were injured, some people were, you can see some ambulance or fire trucks on the image, but I fail to detect the, for example, injury events, attack events in the article, then I can use some information to overwhelm the wrong result or the missed result or recover those missed events, which should be detected from the text. Yes, that's all. All right. Yeah. Thank you.
Hello everyone, this is Li Fu from a second year PhD student from Professor Heng Ji's group. My research topic is liberal IE, liberal information extraction. We propose liberal information extraction paradigm compared with traditional IE, which require human to predefine some schema, and OpenIE, which rely on information redundancy to construct the schema. Our liberal IE paradigm can take human out of IE loop, and we can generate the schema which is customized for the specific input corpus. We have applied this paradigm on various IE tasks, such as fine-grained and typing and universal event schema discovery. We can construct perfect typing schema and event schema. Thank you.
All right, thank you. Go ahead.
Hello everyone, my name is Xiao Manpan, first year PhD student working for Professor Heng Ji. I'm going to talk about my current work, anti-linking based fine-grained anti-typing. Traditional anti-typing focuses on cross-type like person, organization, location. We definitely want more fine-grained types. So basically, give an anti-mention and link this mention to knowledge base and acquire semantic knowledge. For example, we can generate a hierarchical type tree based on DBPD RDF types, and we can use this hierarchical type tree to represent the entity type of this entity. The one advantage of this framework is that it's very easy to move to a new language. Traditional supervised typing system need a lot of label data for each new language. It costs a lot, but develop language-independent anti-linking system is much easier. For example, we can translate or translate foreign entity mention into English and link this mention to English KB. In a current NIST trilingual entity linking evaluation, trilingual includes English, Spanish, Chinese. Our system ranked at top 1 on both typing and the linking task. So, and we didn't use any label data, which is very nice.
Thank you.
Hello everyone, this is Yinglin, first year PhD student working with Hongji. My current project is joint transliteration and linking. First, the basic idea is first I transliterate a word in a low resource languages into English. For example, a Bengali word, maybe it can be transliterated as a word like theory, but not exactly the same. Then I link this word to the English KB. For example, Clinton Hillary, Hillary Clinton, and then use the title to revise the transliteration. But there is another problem. There are some people called Hillary in the knowledge base, but the name end with RE, not RY. So I add some contextual information. For example, there might be some words that are more easy to translate. For example, White House or America, and then I can rank the entity Hillary Clinton higher, and then use this entity to revise my transliteration result. And for some languages that languages lacking of training data, I train the model on related languages and then apply this model to these low resource languages.
Thank you. So you guys should think about how we would do entity extraction on this stream of lightning talk. Klingon to Elvis technology.
Hello everyone, my name is Dilu, and I'm working with Professor Henji, and this is my first year here. And I'm working on the image-based knowledge graph. So when you are trying to extract information from an article in a language which you don't know, a common idea is that you translate this article into a language such as English first. Then it's easy for you to extract the information. But what if it's a low resource language? There are not too many resources for this language. You don't have a good lexicon, and this language is not included in the Google translation. So one idea is that we can regard the images as a universal independent language, and it can be regarded as bridges between all the languages. For example, when the news agencies in different countries are reporting the same event, they will use the similar or even the same images. So in our work, we first find the related images by the key phrase from the articles, and then we find the related English documents using these images, and then we extract the information from these English documents, and then we project these information back to the lower source language. Okay, that's all.
Hi everyone, my name is Anirudh Prabhu. I'm a PhD student with Professor Fox since last fall. I've been working on my research qualifiers this sem, so not much to talk about, but I'm just going to talk about the topic for my research qualifiers. Cool. I've been focusing on situation calculus and its applications. So situation calculus is a logic formalism for which helps represent and reasoning about dynamically changing domains. It was created by John McCarthy, revamped in 1991 by Ray Reiter. What we need to know in situation calculus is there are three main sorts of objects: actions, situations, and fluents. An action can be any sort of thing performed by the agent, like picking up an object, dropping it, moving it, etc. In situation calculus, a situation can be considered a finite set of actions. It's not a snapshot or a state of the world at a particular time, but more like a history of a set of actions that have been performed until then. A fluent is considered the properties of the world at that time. So what we would call a fluent is, relations or functions which are situation dependent, or whose last arguments are situations. As far as applications go, situation calculus has some specific applications. One of those applications is planning, where the agent needs to figure out a set of or course of actions for the agent to reach a specific goal. Another very important or really popular application now is people use situation calculus as a working language for cognitive robotics. So that's the popular one now. Also, situation calculus can also be used for formalizing and reasoning over computer programs. Examples are, Lisp-like programs or Algol-like programs use situation calculus a lot for formalization. That's pretty much all I have. Thank you.
Cool. Thank you.
Hello, everyone. My name is Ahmed Elish, and I'm a first-year PhD student working with Professor Fox. The project I'm working on is an image analysis-based approach to detection and classification of foraminifera in image sample images. I'm working with a group of students from the Earth Sciences department. These brave souls, they go out into the field, they collect samples, and over time they go back to the lab under the microscope, observe the samples, and visually find and identify these fossils. And they keep a tally on the side, and that's basically their data acquisition process. They then use these data sets to derive information about the location where the samples were collected. To help them out and alleviate this pain, I'm proposing an image analysis approach, beginning by creating a database of images of known species that they're investigating. Principal component analysis is used to extract the distinct or the significant features of this database. Then edge detection is applied on an image of the sample to isolate the protozoas in the sample. Then these are based on a classification approach as of yet undecided. These images are then projected into the space of known protozoans or species, and then classification is applied to classify the sample within the image. That's it. Thank you.
So you can figure out a way that you can actually go in the field too.
Right. Hi, my name is Katie Chastain. I'm a PhD student with Professor McGinnis of some number of years. I forget how many, but I'm no longer a master's student, so that's done at least. I've been working this semester. I joined the Bill and Melinda Gates project for their HBGD-KI, Healthy Birth, Growth, and Development. So right now, my work has been assisting with helping to bolster our ontology for describing things in the public health domain with relations to neonatal health. And we've been doing literature review to verify and refine our definitions for all of the terms, a couple hundred terms in the ontology. And I've been focusing on the socioeconomic terms. And so I've told a couple people already, I think, but I have actually spent a couple days in the last few weeks looking for the meaning of happiness. But yes, we're hoping to finish that up in the next month, week, yes, week. So, all right, thank you.
In what namespace will we find happiness?
Let's tag socioeconomics.
Actually, major points for saying HBGD, 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 HBGD.
Yeah, I've had some practice.
Hello everybody, my name is Hao. I'm at the end of the first year under Professor Fox, PhD student, and I'm now started working on the project DTDI, which stands for Deep Time Data Infrastructure. So as we know, the Earth has two major components, the living component and the non-living component, animals, biology, and rocks. So these two components have been co-evolving for millions of years. And yet, the scientists' ability to explore, identify, document these interactions has been limited by a lack of data integration between multiple disciplines, such as petrology, paleontology, and such and such. So, so at this stage, the work of this project is to develop a data frame, which will integrate the data frames from all these multiple disciplines and try to work with the data sources from all these domains of science, geosciences. And now I'm working on this data frame for this semester, and it's still undergoing. So that's for me. Thank you.
Hi, I'm Jim McCusker, and this is literally off the cuff because I decided to do it as we were doing this. So I work in, mostly I work in a field called translational informatics. I try to take information that we already know about biology and medicine and translate it into possible therapies for diseases. And actually the past 7 years before I joined RPI as a staff member, I helped do this for melanoma. I'd actually like to continue doing this at RPI to some degree. I've been working on a project called Redrugs, which basically tries to build a knowledge graph of how cells work at the protein level, what proteins interact with what other proteins. But more generally, I'm interested in trying to figure out how to build a knowledge graphs from pre-existing knowledge, apply probabilities to the assertions in that graph, and figure out what sort of inferences we can make in a probabilistic way. Actually, it's really cool that there's so many text mining people here, but I'm interested in both working with and helping people who are interested in working in the biomedical domain, either on knowledge graphs or on any other problems where that might apply. So please come to me if you're actually interested in that, because I'm more than happy to help with it.
All right.
And I think that's it. Yeah.
That's it. Just, did we have anybody else online that just wanted to give an impromptu talk? No? Okay. We've had Stefan, Josh, Shinavir, and James as just working. They're still on the list. Yeah, yeah. Just listening in, which has been excellent. So I think that's it. I don't see Hendler. Usually Jim Hendler comes up and gives some message, so I won't. I don't know. Deborah, did you want to give a closing great job?
Thanks for signing up. Let everybody came. This has been a great term, and we're looking forward to starting the next term. When are we starting back up next term? You know? Oh.
No, you walked into a talk. Yeah, I know. Just carry on through. Grab a piece of pizza if you want. But
I just sent an email with when we're starting back up again.
Yeah, I've got no idea. One of the things we try to do each term with the TWeds is try to figure out what time works best for everybody. And this term was a little bit more disruptive than it has been. As you know, over the past few years, we've done it every Wednesday night. And what we wanted to try doing this year was shift it around. Let's try some late mornings. Let's try some Mondays, some Tuesdays, some Wednesdays, some evenings. We're trying to mix it around, and we got kind of mixed results. And I was just kind of curious, which of the different times that we did, which worked out better? How many thought that Monday lunchtime was best? Yeah. How many thought that Tuesday evenings was best? A couple. How many thought that Wednesday lunchtime or late mornings were best? Wednesday, we saw a lot of people on Wednesday late morning, like 11 o'clock. Maybe it was the muffins. We had muffins and bagels, but that sort of thing. But anyways,
And everybody thought that Wednesday nights were best.
We didn't do any Wednesday nights, but how many people thought Wednesday nights were actually best? Yeah. People like Wednesday nights. Okay, cool. Maybe we'll go back to Wednesday nights. We could do that. So maybe that's what we'll try to do next. I think a lot of people probably showed up this term on Wednesday night thinking that there was a TWed, and there wasn't.
Yeah, well, I like the consistency.
Consistency.
Although actually with the spring term with snow, although it's supposed to be maybe mild.
Well, so that's what we'll try to do with the coming termers. We'll try to move it back to the Wednesday evenings. How many people think 6 is better than 7? I know 6 is better than 7. Yeah. I know some of you have families and it was a hardship for you to be here tonight. I appreciate that, but hopefully everybody enjoyed this. I think it's great to hear what everybody's doing. I know I could have asked questions all night long. I think every talk there was something I wanted to ask questions and I had to hold it. But that's just me. I'm a nerd. So, is anybody have any comments that they just comments about the whole thing? Did you enjoy the process? People seem to really prepare for it. I hope you didn't work too hard. But
thank you for organizing.
It's my pleasure. With all this material, it's easy to do, right? It manages itself. All right.
Maybe just one more announcement. There may be some room changes with the next semester coming up, so just watch for email.
Oh.
And if
office assignments.
Yeah, office assignments.
Yeah.
So if there's something wrong with your current office assignment, Peter's in charge of this. Actually, send mail to Jackie. That would probably be better.
You reminded me of one more thing about TWeds. Okay, so I forgot the other part. So every term we look for volunteers to lead these talks, and our TWeds are meant to be informal too. We do usually broadcast them, but either at the request of your professor or at your own request. Sometimes we don't. Sometimes the material, because of a partner or whatever, we're not able to talk about it publicly. But generally, we like to do these things. It's somewhat informal discussion. It gives you a chance to talk about it. We've had practice talks as TWeds. We've had crazy ideas as TWeds. It's a good time. So we'll be looking for volunteers prior to next term and even into the beginning of next term. And I know there's a room full of stuff to talk about because you just auditioned. So I kind of cut you off. Anything else?
Okay. So if there's something that you'd like to see changed about your office assignment, I'm going to have you send mail to Jackie because Peter's technically the space czar, but he's not going to be back until late January. So Jackie will collate that. And look for an email message because a couple people graduated and will be leaving, so there'll be a couple of changes.
Yeah.
I guess I don't have any other. Yeah.
So I think comments for all of you, especially for the fresh PhDs who is going to do a research qualifier presentation. So I just want to say my personal experience that I did my first research qualifier presentation as a TWed talk. And I think that's a great opportunity that you can have your friends and also more PhDs come to a talk and give you feedback. As our lab's policy, at least have 3 PhDs to attend your talk for the research qualifier presentation. So although it didn't pass for first time, but I think that's a great opportunity for you guys if you want to do that. So.
Thanks, Ray. Now, who is it that claimed to be? Where's Han? Oh yeah, he said he's a final year PhD. After mistake. That was a great comment.
Never say never.
Yeah, never say never. I'm a final year PhD.
I've been a final year PhD.
Yeah. You're tenured.
I guess I've got one more announcement. I haven't seen the email on this yet, but often the last week of the year, from like December 23rd or so through January 1st, the building's locked. You can still get in with your key card, but normally you can get in between 9 and 5, I guess, without this. But during that last week, you need to get in at all.
Yeah, just be aware during the holidays it can be kind of weird.
Well, campus is officially closed too, so.
Yeah, it's officially closed, but I mean, I've been here that week.
Yeah, but you know, that never stopped a graduate student from getting in there and getting that deliverable done. You know. All right, thank you, everybody. Have a great holiday. And if I can get some help bringing whatever's left upstairs, I think we'll just, somebody, if people could help me, people help. Thank you guys online.